Hello everyone. In this video, we're going to take a look at the tools that we need for coordinate proofs. What the heck are coordinate proofs? Well, it's akin to the proofs that you did earlier in the year, except this time we're on the coordinate plane, hence the name. So in this unit, we are going to use, instead of postulates and theorem, which you did earlier in the year, we are going to use formulas and concrete numbers to prove that shapes are the shape that we think they are. So prove that it's a parallelogram, prove that it's a square, so on and so forth. So there are three tools. Oh, and the numbers that you're going to use for this, the numbers are these points that we give you here. Those are the numbers that you are going to use. Okay, so the three tools or formulas that we use, the first two you've already seen. We got the slope formula. Oops, sorry. We got the slope formula, and you've become very efficient with that. Just remember that lines that have the same slope, they are parallel, and lines that have opposite or negative reciprocal slopes, those are perpendicular. And that's going to be really useful in our proofs to prove that there exists a right angle. You're going to show that two lines or two sides of a figure have perpendicular lines and have negative or opposite reciprocal slopes. The second one is the midpoint formula, which you have been working with most recently. This is a point. It's a midpoint. That's why it's in the form of an ordered pair here. And remember that you're just finding the average of your x values and the average of your y values. And the midpoint is a point that breaks a line into how many equal parts? Well, that's easy because it cuts it in half, so that is 2. So let's just do a quickie example here. I'm finding the midpoint of A and B. I like to label my points x1, y1, x2, y2, just so that I don't get confused. And now I can plug in. I also like to rewrite my formulas just so that I can start to memorize them faster, because when you write stuff down, you get to memorizing it a lot faster. So if you write it down every time, you're going to be in good shape. Now I can just plug in. X1 is 4. I am adding a -8 or just subtracting 8. My y's are 3 plus 7 divided by 2. And this is going to give me a midpoint of 4 minus 8 is -4 divided by 2 is -2. 3 and 7 is 10. 10 divided by 2 is 5. All right, not terrible. We've been doing that. Okay, here's where it gets new. You haven't seen the third tool, which is the distance formula. Okay, so the distance formula obviously is we want to find the distance between two points on a line or a line segment. And so if you look at this picture, we want to find C. So, and we have labeled points A as x1 and y1, and B is labeled x2 and y2 because we're finding the generic form of the distance formula. And we've also drawn in the other sides of a right triangle here. Okay, so we're going to use the Pythagorean theorem to figure out this distance formula. So we need to know, since we want to know C, we need to know what A and we need to know what B are. Well, let's start with A. What's A? Well, what would happen if I put a point right here at the third vertice? Well, to find A's distance, I know that point A has a coordinate of x1 and y1. Well, this point right here at the third vertice has the same y value because I haven't gone up or down. I just went to the right. So all I would need to do is find the difference between this point's x value and point A's x value. Well, I know point A's x value, that's x1. Well, what's this guy's x value? Well, that happens to be the same as point B because it's directly underneath point B. So this guy's x value is x2. So to find the difference, all I got to do is do x2 subtract x1, and I would get the value of A. The same idea can be done for point B. If I put a point right here, I want to find this distance right here. Well, the x value has not changed because I didn't go left or right. I just went up or down. I went up, actually. So this point's y value, we don't know what it is yet, but actually we do because it's the same y coordinate as A's because it's directly in a horizontal line with it. So this y value is y1. And obviously we know that point B's y value is y2. So to find the difference, we do y2 minus y1. Okay, now we're set up. We can just plug this stuff into the Pythagorean theorem. We have a squared plus b squared equals c squared. Now we just plug in. My a value was x2 minus x1, and I'm squaring it. And then I'm adding my b value, which is y2 minus y1. I'm squaring that guy, and that's all equal to c squared. And then from here, to find c, we got to take the radical of both sides. And then therefore, now we have c is equal to, I'm just going to leave this whole side just the way it is. So this is going to be a long radical, and then x2 minus x1 squared plus y2 minus y1 squared. And then this is the actual distance formula because we wanted to know what the distance of C is. Well, that's this right here. So I can just rewrite this as D is equal to that whole thing. And y2 minus y1 squared. Now notice, this looks daunting, but notice that we have x2 minus x1, y2 minus y1. Well, that looks familiar to us because we've already done it way up here in the slope formula, didn't we? You've already worked with situations where you have to do the difference of your x's and the difference of your y's. So it's just in a different format. So don't be afraid. It looks like, oh my gosh, there's a big long radical, but don't be afraid. You've already used this stuff. It's just in a different format. Okay, so let's do a quick example here just so that we have an understanding of what's happening here. So as I did before, oops, sorry. I like to label my points x1, y1, x2, y2 so that I don't get confused. And then my distance formula, I'm going to write it out again. x1, oops, excuse me. I'm already doing it wrong. x2 minus x1 squared plus y2 minus y1 squared. Always write it out so that you can start memorizing it faster. And then you're just subbing in. I got my x2, which is 7. I am subtracting a -3. I put that -3 there just so that I can see that I'm subtracting a negative. It's very important because sometimes you guys just do it like you guys set it up that way, or you even don't set it up that way, and you'll just do 7 minus 3 and you get 4. And then my y2 is -2, and I'm subtracting 5. And I'm also squaring that, and everything is under the radical. So my distance, okay, so 7 minus a -3, that's 7 plus 3, which is 10. 10 squared, that's 100. And then I'm adding -2 minus 5, that's -7. -7 squared is 49. And then, so this is going to equal the radical of 149. And when you plug radical 149 into the calculator, we want to know the distance to the nearest tenth. So when you plug that guy into the calculator, you get 12.2. 12.2. And that's it for distance formula. So it's not terrible. Remember, you've already used the x2 minus x1 and y2 minus y1. And then, so there's only 3 formulas that you need. You need slope, you need midpoint, and you need distance. Right down here in yellow, just make sure that you differentiate between your slope and your midpoint. The slope has a small m, the midpoint has a capital M. So if you're doing a slope and a midpoint in the same proof, just make it obvious that it is you're doing the slope. So excuse me, I like to do like a little small one like this, and I make the midpoint just like real gaudy like that. That's the way I do it. And then again, I suggest that you label your points X1 and Y1, X2 and Y2, just so that you don't get confused and you can easily go back and like, wait, did I do that right? I did. Okay. All right, guys, that's it for this lesson and notes. As always, be safe and be healthy. I'll see you next time, guys. Bye.